Hello everyone. Welcome back to our Geography NCERT series. In our previous session, we explored the Earth in the solar system. Today we move forward to Chapter 2, Globe, Latitudes and Longitudes. This is a fundamental topic that helps us understand how locations are determined on the Earth. Let's start with the globe. A globe is the most accurate 3D model of the Earth. The Earth is not a perfect sphere but is an oblate spheroid. This is because it is slightly flattened at the poles while it bulges at the equator. This is due to the centrifugal force caused by the Earth's rotation that pushes the Earth slightly outward at the equator. This concept becomes clearer when we look at the diameter and the circumference of the Earth. The Earth's diameter at the equator is 12,756 kilometers, while at the poles it is slightly shorter at 12,714 kilometers. Similarly, the equatorial circumference is 40,075 kilometers, while the polar circumference is 40,008 kilometers. This proves that the Earth is in fact flattened at the poles while it bulges at the equator. This unique shape of the Earth is called a geoid, which means Earth-like shape. If you look at the globe, you'll notice a needle or a metal rod passing through the North Pole and the South Pole. This rod represents the axis of the Earth. The axis of the Earth is an imaginary line that runs through the North and South Poles around which the Earth rotates. This axis is tilted at an angle of 23.5 degrees, which is called the axial tilt. This axial tilt is responsible for the different seasons on Earth, like summer, winter, spring, and autumn. Coming to Earth's rotation, the Earth rotates counterclockwise, that is, west to east, around this axis. This rotation is responsible for day and night. To sum up, the globe is a 3D representation of the Earth's surface. The diameter of the Earth is 12,756 at the equator, while it is 12,714 at the poles. Coming to its circumference, it is 40,075 at the equator, while it is 40,008 at the poles. This proves that the Earth is not a perfect sphere, but is an oblate spheroid. The shape of the Earth is called a geoid, meaning Earth-like shape. Coming to the axis is an imaginary line that runs from North Pole to South Pole. It is tilted at an angle of 23.5 degrees. This is called the axial tilt and is responsible for seasons. And the Earth rotates counterclockwise around its axis, that is, from west to east, which is responsible for day and night. To accurately locate places on the Earth, we use a grid system. The grid is made up of two sets of imaginary lines called latitudes or horizontal lines that run east to west, and longitudes or vertical lines running north to south. Let's explore them in detail. First, let's see what latitudes are. Latitude is the angular distance of a place, north or south of the equator, measured in degrees from the center of the Earth. They are imaginary lines running east to west around the globe. They form circles that are parallel to the equator and are called parallels of latitude as they remain equidistant from each other. You can also notice that as we move towards the poles, the length of these latitudinal circles goes on decreasing. Latitudes are measured in degrees, which can further be divided into minutes and seconds. Let's take a look at this diagram to understand it better. You can see the axis of the Earth, the center of the Earth, and the equator, which divides the Earth into northern and southern hemispheres. North latitudes are measured from the equator towards the north, and south latitudes are measured from the equator towards the south. For example, the 30 degrees parallel is 30 degrees away from the equator measured from the center of the Earth. Similarly, we can see 10 degrees north, 40 degrees north, and 70 degrees north of the equator, as well as 10 degrees south, 20 degrees south, and 30 degrees south of the equator. Now let's take a look at the most important latitude, the equator. The equator, or 0 degrees latitude, is the longest circle of latitude. It is drawn halfway between the North Pole and the South Pole and divides the Earth into two equal halves called hemispheres. That is, the northern hemisphere, north of the equator, where latitudes are denoted by N, and the southern hemisphere, south of the equator, where latitudes are denoted by S. Let's see this through an example. Chandrapur in Maharashtra and Belo Horizonte in Brazil are both on the 20-degree latitude. However, Chandrapur is in the northern hemisphere, so 20 degrees N, and Belo Horizonte is in the southern hemisphere, so 20 degrees S. Therefore, specifying N for north of the equator or S for south of the equator is crucial to locating places accurately. Now that we've seen the longest latitude, that is the equator, let's see some other important latitudes. We have the Tropic of Cancer at 23.5 degrees north, the Tropic of Capricorn at 23.5 degrees south, the Arctic Circle at 66.5 degrees north, the Antarctic Circle at 66.5 degrees south, the North Pole at 90 degrees north, and the South Pole at 90 degrees south. You may wonder why latitudes go from 0 degrees to 90 degrees. Well, a circle is 360 degrees. One hemisphere is half a circle, that is 180 degrees. The angle from the equator to the poles is half a hemisphere and therefore 90 degrees. Now let's see the significance of these latitudes and why they are more important than the other latitudes. The Tropic of Cancer at 23.5 degrees north and the Tropic of Capricorn at 23.5 degrees south mark the farthest points where the sun can be directly overhead at noon. Here, the midday sun shines directly overhead at least once a year on all latitudes between these two tropics. In summer, the sun is over the Tropic of Cancer, while in winter, it is over the Tropic of Capricorn. This occurs primarily due to the Earth's axial tilt of 23.5 degrees. We will explore this entire concept in detail in the next chapter when we discuss seasons. This area between the Tropic of Cancer and the Tropic of Capricorn is called the torrid zone and is the hottest zone as it receives the most direct sunlight throughout the year. In contrast to the torrid zone, the midday sun never shines directly overhead on any latitude beyond the Tropic of Cancer and the Tropic of Capricorn. As we move towards the poles, the angle of the sun's rays keeps decreasing, becoming more slanted. The areas bounded by the Tropic of Cancer and the Arctic Circle in the northern hemisphere, and the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere are called the temperate zones. This is because these areas have moderate temperatures as the sun's rays are inclined and not direct. Coming to the Arctic Circle at 66.5 degrees north and the Antarctic Circle at 66.5 degrees south, these mark the boundaries where regions experience at least one day of 24-hour sunlight and one day of 24-hour darkness each year. Beyond these circles, places experience the midnight sun, that is 24 hours of daylight at least once a year, and they experience the polar night, that is 24 hours of continuous darkness at least once a year. The number of such days increases as you move towards the pole. At the North Pole and the South Pole, there are 6 months of continuous daylight, that is when the sun never sets, and 6 months of complete darkness, that is when the sun never rises. These extreme conditions make the polar regions very cold as the sun's rays are always slanting and provide little heat. Therefore, these areas are called frigid zones, meaning very cold. To sum up, latitude is the angular distance of a place north or south of the equator, measured in degrees from the center of the Earth. They are circles that are parallel to the equator and to each other and are therefore called parallels of latitude. The length of these latitudinal circles are not equal and go on decreasing as you move towards the poles. Then we saw the Tropic of Cancer at 23.5 degrees north and the Tropic of Capricorn at 23.5 degrees south. These are the farthest points where the sun can be directly overhead at noon. We also saw the Arctic Circle at 66.5 degrees north and the Antarctic Circle at 66.5 degrees south. These are the boundaries beyond which regions experience at least one day of 24-hour sunlight and one day of 24-hour darkness every year. And we saw the North Pole at 90 degrees north and the South Pole at 90 degrees south. The axis of the Earth passes through these 2 points. We also saw the different heat zones of the Earth. We saw the torrid zone, which means very hot and dry, between 23.5 degrees north and 23.5 degrees south. This is the hottest zone as the sun's rays are direct. Then we saw the temperate zone. Temperate means mild temperatures. This is situated between the Tropic of Cancer and the Arctic Circle and the Tropic of Capricorn and the Antarctic Circle. Here we see moderate climate as the sun's rays are inclined. Then we saw the frigid zone. Frigid means very cold. This is beyond the Arctic Circle and beyond the Antarctic Circle. These are the coldest regions as the sun's rays are highly slanting. Before we move to longitudes, let's see the effect of the sun's rays on temperature. In this image, you can observe that a person standing at the equator receives direct overhead rays of the sun at midday. As you can see, these rays are perpendicular to the ground. Meanwhile, someone standing away from the equator receives increasingly inclined rays of the sun. Let's understand the effect of these direct rays and inclined rays with the torch analogy. Imagine shining a torch straight overhead onto a surface. The light here is more concentrated and is brighter. However, if you tilt the torch at an angle to the surface, the light will now spread over a larger area, making its brightness less intense. When we apply this to the sun's rays, the demarcation of the heat zones becomes clearer. The direct overhead rays of the sun travel a shorter distance, pass through less atmosphere, thereby losing less heat to absorption, reflection, and refraction, and cover a smaller surface area. This results in higher temperatures that are seen in the torrid zone. However, the inclined or indirect rays of the sun travel a relatively longer distance, pass through more atmosphere, thereby causing greater heat loss, and is spread over a larger surface area. This results in lower temperatures that are seen in temperate and frigid zones. Therefore, the regions near the equator are hotter, while the areas farther from the equator become progressively cooler. To find the precise location of a place, knowing just its latitude is not enough. For example, the Tonga Islands in the Pacific Ocean and the Mauritius Islands in the Indian Ocean share the same latitude, that is 20 degrees south. But they are far apart because they lie on different longitudes. So we need another set of reference lines called longitudes to measure how far east or west a place is from a fixed meridian. Now let's take a look at longitudes. Longitude is the angular distance of a place east or west of the prime meridian measured in degrees. Each degree is further divided into minutes and minutes into seconds. Let's take a look at this diagram. Here we can see the center of the Earth and the prime meridian or 0 degrees longitude. Similar to the equator, the prime meridian along with the 180-degree meridian divides the Earth into two equal halves or hemispheres, that is the western hemisphere west of the prime meridian and the eastern hemisphere east of the prime meridian. To locate 90 degrees west longitude, we would have to measure 90 degrees west of the prime meridian. Similarly, to locate the 40 degrees east longitude, we would have to measure 40 degrees east of the prime meridian. Longitudes, also called meridians, are imaginary vertical lines that run from the North Pole to the South Pole. Unlike latitudes, which are circles, longitudes are semicircles. While we saw that latitudes decrease in length towards the poles, longitudes, on the other hand, are of equal length. However, the distance between meridians decreases as they approach the poles where all the longitudes meet. Unlike latitudes, which have the equator as a natural reference point, as it is the longest latitude and divides the Earth into two equal halves, longitudes, on the other hand, are semicircles of equal length and therefore require an internationally agreed upon starting point. In 1884, it was decided that the prime meridian, or 0 degrees longitude, would pass through Greenwich in London, UK, which is home to the Royal Astronomical Observatory. Since then, the meridian at Greenwich has been internationally recognized as the prime meridian, or 0 degrees longitude, that is, the starting reference point for measuring all other longitudes. In this image, we are looking at the Earth from above the North Pole. From the prime meridian, longitudes are measured up to 180 degrees eastward and 180 degrees westward. The longitude of a place is followed by E for east and W for west, indicating its position relative to the prime meridian. The prime meridian and the 180 degree meridian together divide the Earth into two equal halves called hemispheres. That is, the eastern hemisphere, which is 0 degrees to 180 degrees east, and the western hemisphere, which is 0 degrees to 180 degrees west. It is important to note that 180 degrees east and 180 degrees west both fall on the same line. Apart from determining the location of a place, meridians of longitude also play a crucial role in calculating local time. To sum up, longitude is the angular distance of a place east or west of the prime meridian. This prime meridian, or 0 degrees longitude, passes through Greenwich in London, UK, which is home to the Royal Astronomical Observatory. Unlike latitudes, which are circles, longitudes are semicircles that run from the North Pole to the South Pole. Further, longitudes or meridians are of equal length and the distance between meridians decreases towards the poles. Now let's explore the concept of time zones and standard time. The sun rises and sets regularly each day, making it the most natural timekeeper throughout the world. Local time at any place can be determined by observing the shadow cast by the sun, which is shortest at noon when the sun is at its highest point, and longest at sunrise and sunset. At any place on the earth, a watch can be set at 12 noon when the sun is at the highest point in the sky. This time is called local time, which varies from place to place. All places located on the same meridian of longitude share the same local time. When the prime meridian at Greenwich, or 0 degrees longitude, has the sun at the highest point in the sky, all the places along this meridian experience midday or 12 noon. The time at the prime meridian is called Greenwich Mean Time, or GMT, and it serves as reference for all other time zones across the globe. As the rotation of the Earth is from west to east, places located east of Greenwich are ahead of GMT, while places to the west of Greenwich are behind GMT. We know that the Earth rotates 360 degrees in about 24 hours, which means it rotates 15 degrees in 1 hour or 1 degree in 4 minutes. This means there's a 4-minute difference in local time per degree of latitude. For example, when it is 12 noon at Greenwich, or the 0 degrees longitude, at 15 degrees east, the time is 1 hour ahead, that is 1 pm. Similarly, at 15 degrees west, the time is 1 hour behind GMT, that is 11 am. And at the 180-degree meridian, it is midnight, that is a full 12-hour difference from the GMT. However, having different local time for every degree of longitude would be impractical, especially for large countries. To solve this issue, countries adopt a standard time usually based on a central meridian passing through the country. The Earth is divided into 24 time zones, each covering 15 degrees of longitude that represents a 1 hour difference. Time zones are labeled GMT plus 1, plus 2, plus 3 up to GMT plus 12 east of the prime meridian, and GMT minus 1, minus 2, minus 3 up to GMT minus 12 west of the prime meridian. Most countries have a single time zone. However, some large countries with a wide longitudinal extent often use multiple time zones. For example, USA and Canada each have 6 time zones, while Russia, due to its vast east-west extent, has 11 time zones. Now let's explore the latitudinal and longitudinal extent of India as well as its time zone. India has a large latitudinal and longitudinal extent, both spanning approximately 30 degrees. India stretches from about 6 degrees north to 37 degrees north latitude. The southernmost point of India is the Indira Point in the Andaman and Nicobar Islands, located at 6 degrees north. The southernmost point of the Indian mainland is Kanyakumari at around 8 degrees north. The northernmost point is in the Union Territory of Ladakh that lies at around 37 degrees north. The Tropic of Cancer at 23.5 degrees north runs approximately through the center of India. Coming to its longitude, India spans from 68 degrees east in Gujarat to 97 degrees east in Arunachal Pradesh. This longitudinal spread of 30 degrees results in a local time difference of approximately 2 hours between Gujarat in the west and Arunachal Pradesh in the east. To avoid confusion and to maintain uniformity, India adopted a single standard time based on a central meridian. The Indian Standard Time, or IST, is based on the 82.5 degree east meridian, which passes near Prayagraj in Uttar Pradesh. The local time at this meridian is used as standard time for the whole country. IST is also represented as GMT plus 5.5 hours. This means that India is 5.5 hours ahead of GMT. So, if India and England have a cricket match in London that starts at 2 pm GMT, then in India it will be at 7:30 pm IST. To sum up, India's latitudinal extent is from 6 degrees north to 37 degrees north. India's southernmost point is the Indira Point at 6 degrees north, while the southernmost point of the mainland is Kanyakumari at 8 degrees north. The northernmost point of India is in Ladakh at 37 degrees north. Coming to its longitudinal extent, India spans from 68 degrees east in Gujarat to 97 degrees east in Arunachal Pradesh. Coming to India's standard time, the Indian Standard Time is GMT plus 5.5 hours. This is based on the 8.5 degree east meridian, which passes through Prayagraj in Uttar Pradesh. The 180 degree meridian, directly opposite the prime meridian, is known as the International Date Line. It is an imaginary line that runs through the Pacific Ocean, and it marks the change of date on the Earth. Along the international date line, the date changes by exactly 1 day when crossed. For example, if it is Monday, April 2nd on the west side of the international date line, it will be Sunday or April 1st on the east side. While the date changes, the time of the day remains nearly the same, of course adjusted for time zones. For instance, both sides of the GMT plus 12 and minus 12 time zones might show 11 am, but one will be on Sunday while the other will be Monday. The direction of travel determines whether a day is added or subtracted. If a traveler crosses the international dateline from west to east, they go back one calendar day, for example, from Monday to Sunday. However, if a traveler crosses the international dateline from east to west, the calendar date moves forward by one day, for example, from Sunday to Monday. Simply put, when crossing the international dateline eastward, you subtract one calendar day, while when crossing the international dateline westward, you add one calendar day. The international dateline is not a straight line. Instead, it zigzags around the 180-degree meridian, especially near regions like the Bering Strait and island groups such as Micronesia, Melanesia, and Polynesia. If the international dateline instead followed a straight path, it would split some island nations into different date zones, leading to confusion. To maintain a uniform date within the same country or island group, the line bends around them. To recap, the international dateline runs through the Pacific Ocean at roughly 180 degrees longitude. This marks the change in date, and the line is zigzag to ensure uniformity of date within the same country or island group. While traveling west to east across the international dateline, a traveler has to subtract one day from the calendar date. On the other hand, while traveling east to west across the international dateline, a traveler has to add one day to the calendar date. That brings us to the end of Chapter 2. In the next video, we'll explore Chapter 3, Motions of the Earth. If you found this helpful, don't forget to like, share, and subscribe to Clinch It for more such content. Thanks for watching, and I'll see you in the next one.